Another one. Evaluate the indefinite integral. Integral x squared over 1 plus x squared all squared dx. Well, what form is this? This is of the form a squared plus u squared. That's right. So we have 1 plus x squared inside the parenthesis, which is of the form a squared plus u squared, where a squared is 1 squared, so a equal to 1, and u squared is x squared, u equal to x. And so what is our substitution? Is u equal to a tan theta, u equal to a tan theta, u equal to x. So x equal to a tan theta, a is 1. So our substitution is x equal to tan theta. If x equal to tan theta, what is dx? Okay, dx equal to secant squared theta d theta. And what is x squared? X squared is tan squared theta. So in here we will replace these two x squares by tan squared theta, replace the dx by secant squared theta, and that gives us the integral is now x squared becomes tan squared theta, 1 plus x squared become 1 plus tan squared theta, and that quantity is raised to the power of 2, and dx is secant squared theta d theta. What is the next step? What is 1 plus tan squared theta? 1 plus tan squared theta is secant squared theta. So replace that by secant squared theta. Now this is secant squared theta raised to the power of 2. And you can see this secant squared theta and a secant squared theta will cancel, leaving a secant squared theta. Remember, secant squared theta all squared is secant squared theta times secant squared theta. One of them will cancel and the other will remain. And you notice I just cancel the power. That means this is going to stay. So that will be integral tan squared theta divided by secant squared theta d theta. How would you simplify that? Well, this is not a form we can integrate easily, is it? So whenever you have tan, cot, cosecant and so on, try and change them to sine and cos. Tan squared theta is sine squared theta over cos squared theta, and secant squared theta is 1 over cos squared theta. There's a theta missing there. And what is this? Try it in your mind. It is sine squared theta over cos squared theta times, reverse and multiply, cos squared theta multiplied divided by 1, and cos squared theta and cos squared theta will cancel, leaving us with integral sine squared theta. I hope you can deal with that. And how do you integrate sine squared theta? We had developed a method of doing that. You need to replace sine squared theta in terms of what? Cos of 2 theta. What is cos of 2 theta in terms of sine squared theta? Cos of 2 theta is 1 minus 2 sine squared theta. Therefore, what is sine squared theta? Sine squared theta is 1 minus cos 2 theta all over 2. We have done this several times. If you have difficulty, go back and review that again. Let me write down that identity one more time. It is cos of 2 theta is 1 minus 2 sine squared theta. Therefore, 2 sine squared theta equal to 1 minus cos of 2 theta, and divide both sides by 2. You get sine squared theta equal to 1 minus cos 2 theta all over 2. Alright, that's what is in here. And in order to evaluate this, we can split this into 2 if you want. Is that right? Or we can factor the 1/2 outside and write it as 1 minus cos 2 theta d theta. Alright, we can integrate this. What is integral of 1 d theta? Integral of 1 d theta is theta. Integral of 1 dx is x. Integral of 1 dv is v. Integral of 1 d theta is theta. Minus integral of cos 2 theta d theta is, well, I hope you remember, integral of cos theta d theta is sine theta. Integral of cos a theta d theta is sine of a theta divided by a. So integral of cos 2 theta d theta is sine of 2 theta divided by 2. So that will be 1/2 integral 1 d theta is theta minus integral cos 2 theta d theta is sine of 2 theta divided by 2. Well, are we finished? No. What do we need to do here? We have the original integral is in the form of in terms of x. We need to get these results back in terms of x. How? Go back to our original substitution. What is our original substitution? Well, I simplified this. Sine of 2 theta is 2 sine theta cos theta. But that will be much easier when you go back to our triangle. Our original substitution is x equal to tan theta. So what do? We use this substitution to construct a triangle. What is therefore tan theta equal to? Now, if x equal to tan theta, I hope you understand this skill. If x equal to tan theta, then theta equal to arctan of x. That's the inverse function that we talked about so many times. So if x equal to tan theta, then theta equal to arctan x. That means in these results, this theta can be replaced right away. What is theta? Theta equal to arctan x. And if x equal to tan theta equal to x over 1, opposite side is x, adjacent side is 1. Tan theta is opposite side divided by adjacent side. So we know the opposite side, we know the adjacent side, therefore what is the hypotenuse? That is theta. X is the opposite side, 1 is the adjacent side, therefore the hypotenuse will be, the square of the hypotenuse is 1 squared plus x squared. Therefore the hypotenuse will be square root of 1 plus x squared. There you go. So in this case, therefore, we need to now find the value of sine theta and cos theta. The value of theta we already know. What is the value of theta? Theta is arctan x. Alright, in this triangle, what is sine theta? Sine theta is opposite side divided by the hypotenuse. That will be x divided by square root 1 plus x squared. There you go. And cos theta is adjacent side divided by hypotenuse, which is 1 over square root 1 plus x squared. So, in the results that we obtained in terms of theta, we replace theta by arctan x, replace sine theta by x over square root 1 plus x squared, replace cos theta by 1 over square root 1 plus x squared, and that gives you this result. 1/2 of theta, 1/2 arctan x, minus sine theta cos theta. You can see square root 1 plus x squared. Here, this one. 2. This one is 2 sine theta. 2 sine theta is 2 times x over square root 1 plus x squared, times cos theta is 1 over square root 1 plus x squared. And that gives you, you can see the 2 and the 4 cancels, leaving a 2 at the bottom. And x times 1 is x. Square root 1 plus x squared times square root 1 plus x squared is 1 plus x squared, and that will go to the denominator. So our answer is 1/2 of arctan theta minus x divided by 1 plus x squared. Now here, if you notice, the 2 and the 4 goes, leaving a 2 there. That means there is a 1/2 in this term and a 1/2 in the first term. It is that 1/2 that has been factored out. So 1/2 and 1/2 has been factored out, leaving arctan theta minus x divided by these two multiplied gives you 1 plus x squared. And that is the final result. Alright, let's try another one. Evaluate the integral. Integral 0 to 2. We have a definite integral here.